you remember.
Hello friends, welcome to 7-minute study. In this video, I'm going to continue the topic which I have raised in the previous video of the types of agents. In the previous video, I've talked about intelligent agents. What are they basically? And types. I've started about talking about types of agents, which are the simplex reflex agent, simple reflex agents, and the model based reflex agent. In this video, I'm going to continue the topic of types of agents. The first type of agent, or the third type of agent, based on the continuation, would be the goal based agent. So what's a goal based agent? A goal based agent is nothing but an agent which stores the state description as well as it stores the goal states information. So previously, as we have seen in the model based reflex agent, we also deal with the state. All right, in this also we deal with the state, but here the major difference is that in a goal based agent we have state, the current or the previous states, and even the knowledge about the future state or the goal state we want to be in. So before taking an action based on a perception, we'll be considering the past state or the just before state of the perception, and then based on the relation between state and the perception, we are going to consider a condition. Then we are going to arrive at a decision where we'd be taking a current action about that, and then we would be modifying state. So that would be the model based reflex agent. The only difference between this is that we have state, and then we even have the goal state in the goal based agent. That's it. There, in the model based reflex agent, we just arrive at a goal state without having any prior knowledge about it. Here we are going to have a prior knowledge and arrive at the goal state very nearer to it, and then we are going to take measure the accuracy at sometimes if we want to. This the measuring of accuracy is taking particular decisions can be learned in machine learning in the future videos. So for now, let's continue with the topic. And properties and characteristics of goal-based agents would be that the goal-based agent works simply towards achieving the goal. All right, there's no other topic. If we have a goal state, there's no other possibility or the working of or the thought of an agent that it might be having other possibilities too. So the agent is going to just consider the state, goal state, and the perception, and then arrive at the goal state very nearer to the goal state. All right. So for tracking goals, it needs to search and plan. That's the major goal based agent processing. It needs to be searching and planning the various possibilities of reaching the goal state most efficiently. All right, and we can change quickly the goal based agents behavior based on the unknown or known goal. This is going to have lots of processing, but it's going to process a little faster than the utility based agent because of some the goal state is already there and we have to just arrive to it. All right. So some example of the goal based agent would be agent searching for a solution of an 8 queen puzzle, because this is an apt example, because 8 queen puzzle we have a certain state or a certain definition of states we would be like to reaching, but the goals, that's the goal state where we want to reach, but right now we are at some initial state. All right, as we have the goal state and the initial state, we can just, based on the perceptions of the action, we can just take we need to allow pitfalls, we need to allow the major sometimes we need to the 8 queen puzzle, we need to have only some conditions like based on two queens in a row or two queens in a column. I'm going to talk about the Wumpus World puzzle and the 8 queen puzzle carefully in the future video. So right now don't take stress about that. So just concentrate about what goal based agent is. It's going to take goal state and the initial state or the given state as inputs. Based on the perception, is going to take what action is going to do and how the world needs to be evolved. This is the goal state. All right, state and goal state. What's the world like now, and then what will be how close to the goal state would we be there if we like go with a particular action. If we go with a particular action, if we are far away from our goal state, then we are going to consider other possibilities. So as I told, this is going to process fast, even though it's being performing both retrieving, storing, and searching. All right. So the next kind of agent would be the utility based agent. All right. Yeah. And utility based agent is nothing but an agent which is having a complex environment where only goals are not enough to for the agent design. Additional information in the base of utility function is also needed. All right. Here I haven't mapped. I guess like while discussing, I'll be mapping from state and all other required changes. So what's happening here is that here too we have an additional thing, like in the goal utility based agent and the goal based agent, there's only a difference that if we are in a goal state, how satisfied or happy would be. So that's the only difference between utility agent and the goal based agent. I'll be showing the mapping first, and I'll discuss about the difference. So first let me map it carefully. Right. So based on the difference, you'll be just understanding, and you can just understand the properties of utility, like utility based agent and the goal based agent. See, here in a goal based agent we have like what the world is like now, and what it will be what the world would be like if we perform an action A based on the state and the other perceptions. All right. So we'll be deciding upon what action should be done. All right, based on the goals. Here we are not having a goal. Instead, we are going to have an utility function. Like it would be describing how happy we would be if we perform a particular action. Alright, there we are going to just check if we are going to reach a particular goal state or not. Here we are going to check if the state reached is satisfying the particular conditions or the requirements of the user or not. Alright, so the main characteristic of this utility based agent is that utility function maps a state to a real number which describes the degree of the best performance, like the degree of best performance or satisfiability of a requirement of a user. All right, this is going to be modifying itself based on the utility requirements of a user. All right, this is the most important or most used utility, most used example right now. And if a most efficient type of agent would be a utility based agent, because it would be modifying itself just like a goal based agent, but not only to reach the goal state but also to check if that is the only efficient goal. There we are in the goal based agent, we are going to prefix ourselves, like that's the goal state and we have to reach that's it. We are not going to cross check if the goal state itself is efficient or not. And in utility based agent, instead of just fixing getting it fixed, like the goal state we are having is the best state we could ever be in, we are going to consider the utility function of each goal, and based on the real number function we are going to judge the performance. Even though the utility based agent is the most efficient agent we have discussed about so far, we are not going to use the utility based agent in most of the applications, but we will be using the utility based agent in such applications where their usage is going to show the maximum possible efficiency ever, like compared to using any other agent. So such an example would be that of the military planning robot, which provides certain examples or certain plan of action to be taken. Its environment is too complex because we won't be able to predict the positions of bombs or any other soldiers, and the expected performance would also become high in case of using a utility based agent. All right, so let's go to the learning agent, which is another type of agent similar to intelligent agent, not the subtype of an intelligent agent. All right, subtypes of intelligent agents are the goal based goal based agent, utility based agent, and simple reflex agent, and also the model based reflex agent. All right, and a learning agent is also a type of an is also another type of an agent which is different from an intelligent agent. All right, in intelligent agent we are going to learn about from certain rules or certain states or some certain goal states or certain utility functions, but in case of a learning agent we are just going to learn from the environment based on some certain conceptual components. Okay, all right, we are going to have some unknown environments, we are going to search for a pattern between them, and then we are going to learn concepts from the environment or any other environment we are going to give it as a result. All right, so the basic conceptual components which are required for a learning agent are learning agent, the learning element or the learning agent, and then the performance, the performance element, and then the critic, and then the problem generator. All right, let's just brief out what are the independent tasks of each conceptual component, as it's going to contribute towards the concept we are going to derive from unknown environment in order to judge a known environment. All right, so what's a learning element? All right, learning element is the one which is going to have some predefined knowledge and then generate the changes to the performance element based on the performance factors such as efficiency or capabilities and other factors. It's going to return a function of knowledge to the learning element or agent element. All right, and then based on the learning elements decisions, it's going to generate some learning goals, like we have to we have learned a certain concept from the unknown environment. It's going to generate that concept as a learning goal to the problem generator, and then the problem generator is going to just match with if the problem is being solved or not, or the problem is matching the learnt goal. All right, and then is going to measure the performance of each each problem versus learning goal, and then generate a feedback using critic conceptual component. All right, that's what's happening. The flow would be like the learning agent is going to come first, the performance element is going to be like judging the each unknown environment, and for a known environment there will be a problem generator, and the problem generated in the known environment is going to matched up or is going to compared with the learned environment or the learned goals from the unknown environments, and then the feedback is generated from the critic based on the performance standard, which is going to be compared with the problem and the learned goals. All right, based on that we are going to classify environments. So an example of a learning agent would be an aeroplane driving agent which continuously learns from the environment and does the safe plane driving, because this is an apt example, because we have an aeroplane and the environments the aeroplane is going to travel might be unpredictable. All right, or the unknown environments, and the plane is going to learn from the unknown environments to judge them based on a learnt goal, with the problem of whether to drive in a straight direction or to take a diversion or to just go to lesser altitude or to increase the altitude which it is orbiting in currently, and all the decisions are going to matched up against the problem, and then based on the performance a critic is going to give a feedback, and the feedback is important to judge if the decision is going to be the best decision. If not, there will be changes and the knowledge is certainly going to be added or modified. All right, thanks for watching the video. This is the structure of the learning agent. You can just take a screenshot of it. Thanks for watching the video. Please subscribe to stay updated with all the videos I'm going to upload. Thank you.